Welcome and thank you all for joining us today for our Buy Sales webinar, From OpenRAN to Reality, Leveraging OpenRAN for Indoor and Vertical Applications. Here to present from Buy Sales is their CEO, Gary Ford, and Project Manager, Majdi Shami. And representing from Winncom Technologies, our Solutions Architect, Mike Hughes. If anyone has any questions throughout the presentation, please feel free to add them into the chat and they'll be addressed during the session. Gary, you're up.
Thank you, Dawn. Hi, everybody. I'm Gary Ford. I'm CEO of North and South America for Buy Sales. We're glad you joined us today. We're going to discuss the ORAN and the technical details as well as the deployment activity related to it. And it's a pretty open conversation for us. So we're looking forward to the feedback we get throughout the meeting. Just to give you a little background on Buy Sales, if you're not aware, we've been around for about 11 years, 5G and LTE manufacturer of small cells, fixed wireless, private networks. Our products work very well for all those activities. We support the CBRS model in North America and the bands of spectrum that are available in the South American countries. So we're excited about our products that we can share with you today. Although at a high level, we're going to talk about this open network and what it means to you. So in order to start that, before we get in with Majdi and Mike, I want to ask a quick survey for you to fill in, just so we have a good understanding of who you are and what your objective for this call is. So we basically want to understand where you are from an ORAN perspective. And what does it mean to you and how detailed of a conversation you want to have today? Because with Mike and Majdi, they can get as detailed and we'll still be on this call tomorrow afternoon, or we can keep it as high level as it is interesting to you. So we can look at the results in just a minute or two. So how much do you know about ORAN? Well, what? That's a good way to say I need the details as well as the high level. I get the concept. Let's get to the details. I understand it. Let's talk deployment. Or you're an expert and you've actually deployed it and you have some real life experience with it. So if you just take a second and answer that, that would be great. That'll give Majdi and Mike a good understanding of where we go. So thank you again for joining us. Enter all your questions in the chat and we'll get to them as we throughout the call. So Majdi, as they're finishing up the poll, I just wanted to let you get started and introduce yourself.
Yeah, thank you, Gary. Yeah, my name is Majdi Shami. I'm the product manager with Buy Sales. So let's just wait for yeah.
The poll is closed and it looks like the majority of them are oh what?
Oh my God. Okay.
So there's the perfect thing to include, right? I'm glad we're having the conversation then.
Yeah. All right. Shall I start or are we waiting on more?
Oh, that's good. I think it's good.
Okay, good. Again, welcome to our webinar. Today, we will explore how OpenRAN modular architecture can be adapted and optimized for diverse indoor environments, moving beyond the traditional macro deployment to serve the specific needs of industries such as healthcare, manufacturing, logistics, hospitalities, and large venues. By the end of this session, hopefully, you will have both the technical insight and the practical context needed to evaluate and plan OpenRAN deployments. So let's get started here. All right, so what is ORAN? Right, ORAN is a disaggregated, open, and intelligent approach to building mobile radio networks. It replaces the proprietary single vendor RAN system with a modular architecture, standardized open interfaces, and cloud-native software to enable multi-vendor interoperability and AI-driven automation. So you can see here on this diagram. So let's walk through the evolution of RAN architecture. So some time ago, when we started the actual mobile industry, we start with what's called DRAN, which is a distributed RAN. This is a traditional setup where baseband units and radio units are tightly integrated and deployed at each cell site. So it's highly integrated solution, comes with higher cost and less flexibility. Next, we move to CRAN, which is centralized RAN. Here, basebands unit are pooled in a like central location, like hotel. So they call it sometimes pool hotel. This will improve resource utilization and coordination across cells. And also it reduces cost and enhanced, it has the spectrum efficiency. Building on that, we then move to virtualized RAN, which in this model, the baseband functions are virtualized and run on commercial off-the-shelf servers. It has its own benefits, we started the cloud-native scalability automation, and software-driven innovation also started with the vRAN technology. Finally, that's why we're here. It's the OpenRAN or the ORAN. This is the most open and interoperable solution where not only are functions virtualized, but all interfaces are standardized and open and disaggregated. This means that operators can mix and match hardware and software from multiple vendors. Also, AI-driven optimization was introduced through what's called R apps and X apps, and I'll cover that through the presentation. This will lower, definitely it will lower both CapEx and OpEx, while it accelerates innovation at the same time. So the journey goes from tightly integrated hardware in DRAM to the open, interoperable, software-driven ecosystem of ORAN. So let's look at now at the benefits of OpenRAN. First, as you can see here in the diagram, the mixture. OpenRAN breaks vendor lock-in. So operators can source radios, basebands, and software, not only hardware, and software from different suppliers. This strengthens the supply chain and promotes healthy competition. Second, it's innovate. So by opening up interfaces and allowing third-party X apps and R apps, OpenRAN accelerates innovation. So it enables a new user experience because of the AI-driven network optimizations that's been introduced. So these are the two, then we go into reduce. Here, reduce. OpenRAN helps reduce time to market. So everybody's looking for, fast time to market. OpenRAN is the technology for that. Why? Because the ecosystem is multi-vendor and software-driven. So operators can deploy new features and services faster compared to like a single vendor, because they have like their own roadmaps and release cycles. But here you have a selection of different vendors provide different pieces of this puzzle. Finally, it's flexible. OpenRAN offers the flexibility needed when you design and develop your network, so operators can tailor a solution for specific needs, whether that's a stadium with high density or a factory or a hospital. So it is, you just tailor the solution to your needs. So in summary, OpenRAN well, delivers vendor diversity, faster innovation, reduced deployment cycle, and of course, the greater flexibility. All of which, critical for scaling 5G into new markets and verticals. Okay, let's go to the next slide here. So traditional RAN versus OpenRAN. On this slide, we're comparing classical RAN, the vendor-driven model, against ORAN, which is open and disaggregated, as I mentioned before. So let's go row by row quickly here. Architecture. In traditional RAN, everything is bundled together. You have the monolithic BBU with tightly integrated RU. Often it's like referred to as a black box. While OpenRAN breaks this apart into three parts: the CU, which is the centralized unit, and then DU, the distributed unit, and then RU is the RAID unit. This it allows operators to choose, the best-in-class components for each function. We move to interfaces. Classical RAN uses closed vendor-specific interfaces. This means you're locked into one vendor ecosystem. While OpenRAN, on the other hand, relies on open, standardized interfaces. This is the magic of it, the standardized interfaces, and I'll explain that later on. Things like the 7.2, this is the split that enables OpenRAN. And we have so many other interfaces, standardized interfaces like A1, E2, O1, and O2. This ensures interoperability across vendors. Hardware. In a proprietary RAN, you're tied to a specialized hardware, often built on custom ASICs, while OpenRAN can run on commercial off-the-shelf servers and cloud-native platforms. This would reduce costs for you and make scaling much easier. Vendor ecosystem. Closed RAN means single vendor lock-in, again, as we said, while OpenRAN flips that. It enables a multi-vendor environment, while you can competitively source equipment and software from different vendors. Scalability, yeah, this is important because in a traditional RAN, scaling depends on your vendor's roadmap, while OpenRAN is more flexible. You can scale from small indoor cells all the way up to a full macro deployment without waiting for proprietary updates. Innovation, yeah, it goes without saying that, the vendor controlled are all, usually they're slow, while the OpenRAN accelerates innovation through the apps that I keep mentioning, allowing faster adoption of AI and machine language into the RAN. Cost model, closed system brings higher CapEx and OpEx since you're buying proprietary hardware and services, while OpenRAN lowers CapEx with COTS, over-the-shelf hardware, and also it will reduce OpEx through automations because these the stack of the OpenRAN provides apps with that will automate a lot of your activities. Management in classical RAN, it's all done through siloed vendor-specific NMS or AMS system, while in the OpenRAN realm, it is unified across SMO, which is services and management orchestrations, and RIC-driven optimizations. Finally, future readiness, proprietary LAN, it is harder to integrate with things like MEC, which is the mobile edge computing or slicing, while OpenRAN, actually, it's designed from ground up to support edge computing, slicing, and vertical applications. So so the big picture here is traditional RAN is rigid, closed, and costly, while OpenRAN is open, flexible, and designed for innovation. That's why many operators actually now and enterprises are considering it for both outdoors and indoors deployments. All right. Shifts in connectivity needs. The evolving user behavior and also the emerging applications and increasing data demands, the reshaping the connectivity requirements. So looking at for instance, number one here, the indoor traffic dominance. Over 80% of mobile traffic is now generated indoors. And much of it is high throughput and also requires low latency also for factories and different enterprises, such as AR, VR collaboration. They require low latency, real-time video analytics, and dense IoT telemetry. So this is shifting design priorities from simply achieving coverage. It's no longer about just coverage. We need to ensure the needed capacity and quality of service as well. Number two, macro penetration loss. Macro only, macro solutions struggles indoors, because we have the RF attenuation through low E glass. Usually you will lose up to 25 dB just because of the glass in the buildings. And you also lose up to 30 dB due to the concrete and walls. So for instance, if you have an outdoor RSRP of, let's say, minus 85 dBm, this can degrade to below minus, let's say, if you add this up, minus 110. So after one or two walls, so it will push your devices to a lower MCS and it will raise the blur. Even if you increase the macro power, outdoor macro power, that will raise the frequency, the intercell frequency, and it will not resolve your indoor issues here. So vertical specific challenges. If we look at hospitals, they need electromagnetic interference, compliance, and low jitter because of, for continuous patient telemetry, and imaging workflows. This is a must. So ORAN can resolve that. I can explain that later also. Factories, it depends on the ultra low latency, where it's less than 5 milliseconds is needed. Availability, of course, we need to have at least 5 nines, and roaming, robust roaming for the autonomous, guided vehicles, the AGVs. Large venues, large venues may exceed 100,000 concrete users in stadiums, and concerts. So, and they all need to connect concurrently. So deploying high order MIMOs, carrier aggregation, and load aware scheduling, where you can actually manage the load to avoid collapse at peaks. So in summary, each vertical benefits from tailored indoor cell rather than relying on, outdoor signals. So that's the whole point here, just the how we resolve all these issues indoors. The last point here is OpenRAN fit. When we talk about the fit of OpenRAN for indoor deployments, the key advantage here it's the modular architecture. So unlike traditional RAN, where you actually buy monolithic solutions from a single vendor, OpenRAN allows you to mix and match the components that you need. So this modularity is actually a big deal. It means that the same OpenRAN can be scaled from a single factory floor to a nationwide multi-site deployment, all without overbuilding or overpaying for unused capacity. Two, OpenRAN advantages indoors. So again, we keep saying that OpenRAN disaggregated model let you deploy only what the site needs. So number one here, multi-vendor interoperability. The ORAN Alliance has specifications to enable the ORU, DU, CU from different vendors to interoperate. This widened sourcing options reduces the lock-ins and let you choose the best of breed radios for specific bands or form factors. Two here, it's flexible functional splits, and this is actually the most important part of OpenRAN. We have the split 7.2, which keeps time critical physical functions near the radio, with the front haul latency under 250 microseconds. Also, split 2 allows the CU centralization for scale or multi-site control. You can also mix splits. You don't have to stick to only split 7. You can also in your solution you can have different splits according to your needs in the same building actually. 3, incremental scalability. Here, what it means, like you can start with a pilot cluster on one floor. You validate all the KPIs, latency, throughput, handovers, then expand horizontally to adjacent floors and also vertically across buildings. So with containerized, the actual containerized solutions and the COTS, the over-the-shelf hardware, scaling is largely a software exercise. It's no longer hardware. It's just you can add RU sectors. This is where actually only the hardware comes in, and compute, which is the MACs as traffic grows. So that's the scalability that ORAN offers. Also, we talked about the CapEx and OpEx efficiency. When you run the actual DU and CU on the x86 or ARM platforms and use the open front haul switches, typically this reduces your total count of ownership by 40% versus proprietary indoor systems. 5 here, rapid future adoption. Because functions are software defined, as I indicated, you can roll out AI-assisted radio resource management, for instance, DSS, which is dynamic spectrum sharing, network slicing, new security features via updates. It's like your iPhone. You just update as more updates coming or new features come in. So the X apps. So I'll explain the X apps and R apps later on, but these are think of them as like app store for the RAN, just an app store that you can have a lot of programs and functions that automate the actual RAN. You can, for instance, you can use it for anomaly detections, beam optimizations, continuous RF tuning, without site visits. That's the beauty of it. That's how you save an OpEx. Everything is done, remotely via cloud, by these apps. All right. Moving to the next. Bridging outdoor and indoor. As we move from outdoor macro coverage to dedicated indoor system, one of the biggest challenges is ensuring that they operate as a single seamless network from the user perspective. You don't want to be isolated. I mean, indoor, yeah, but you need to also communicate outdoors. Seamless mobility. So handovers using XM or NG based mobilities. This preserves calls in data sessions. So users move between macros and indoor cells freely without losing any connectivity. This is done by there is some measurements, event-based measurements that I'm not sure how if you're familiar with this, A3 or A5, they need to be adjusted to make sure that the offset is tuned for the building edges to avoid what's called handover storms when you design your indoor networks for ORAN. Another point is the actual unified core connectivity. What's good that indoors and outdoors, the RAN part, they share the same 5G SA or NSA core, where policies, quality of service, and security are enforced constantly. So you're not reinventing the wheel. We use the same core. So, but for private networks, interworking with the public core it's done via roaming. Or network slicing also, just to preserve your identities. Centralized management using a single service management and orchestration, which is called SMO. This is also an important part in the stack of ORAN, and RIC, which is the RAN Intelligent Controller. These centralized management, they manage your RF parameters, software versions, alarms and KPIs for both macro and indoors. You also have the SON, which is the centralized self-organization network. It handles the PCI planning and neighboring lists. Last is the neutral host capabilities. We support, it supports the MOCN and the MORAN to allow multiple MNOs. This is important because you can have multiple MNOs sharing the same indoor infrastructure while maintaining spectrum separation per operator quality of service. So the same indoor infrastructure can be used with multiple PNOs. This is powerful for airports, malls, stadiums, where multiple carriers require strong in-building services without duplicating hardware. So they all use the same hardware indoors. For key vertical use cases, this is the actual core of our presentation here. So let's explore how OpenRAN makes the diverse needs of vertical industries and how or why it makes more sense than traditional RAN. Let's look at manufacturing. In manufacturing environments, the reliability and low latency are critical, right? Because you have the robots and automated guided vehicles, they need control. They need under 5 milliseconds of control loops, is called. So with OpenRAN, we can combine the URLLC, which is the ultra reliable low latency communication profile, with the mobile edge computing, which is the MEC. Placed in the right, let's say in the right shop floor. This will ensure real-time control of machines. And when we add AI at the edge, when I say the edge, it's like the DU with the actual apps that control the entire use case. It enables the real-time defect detection in case of manufacturing, and also predictive maintenance. So these apps, They also, for instance, in manufacturing factories, a lot of interference takes place here. It will work on that, reducing the spectrum noise, making it, making this environment much more managed. So this is how the actual ORAN, use cases when it comes to manufacturing. Healthcare, in hospitals, the requirements go beyond performance. It's compliance and safety are paramount here. So OpenRAN can be designed, or it is designed to health insurance and general data protection, electromagnetic interference compliancy. So, so the equipment do not interfere with sensitive equipment like, MRI machines and ventilators. You don't want the radios interfere with all of this equipment. And at the same time, the network must meet the health insurance and protection standards as well. This is also built in. So OpenRAN makes it easier to enforce secure data flows. And it integrates seamlessly with the picture archiving in the medical imaging also that's been used in hospitals. Using slicing, that we prioritize life critical applications. So a patient monitor, for instance, will always take precedence over guests streaming videos in hospitals. So these are the first two verticals. Let's go to the rest. Venue and transport hubs. Now, think about a stadium, airport, or train where, we're talking about tens of thousands of devices connecting at the same time. Traditional RAN definitely will struggle here. While OpenRAN allows neutral host deployment, meaning multiple operators can share the same infrastructure while still maintaining separate quality of service levels. This is used by slicing features. So fans in stadium can stream instantly, while operations team maintain their own secure connections. So REC-driven automation can even balance load dynamically across sectors. So the networks, the networks won't collapse under peak demands. So that's from venue and transport hub perspective. Education and retail. In education, the story shifts now to uplink demand. Virtual classrooms and AR/VR training modules generally they require far more uplink traffic than downlink. We have the smart shelves, smart retail stores now. We have the IoT sensors, video analytics. We're pushing a lot of data upstream. So OpenRAN allows to optimize specifically for this kind of uplink heavy environments. With the AI-driven apps, we can dynamically allocate resources to where demand spikes, creating a smoother experience for both students and customers. Last here, we have, this is what I keep talking about, the R apps and X apps. The beauty of OpenRAN is customization, and this can be done using the R apps and X apps. So operators can tune the network to the exact needs of each vertical. For example, factories, can get interference management applications, while stadiums can run mobility tuning apps to handle dense handovers. So this is something proprietary RAN does not allow, it is locked down, but OpenRAN continuously evolve the network, adding features and policies without waiting for vendor roadmap. So across manufacturing, healthcare venues, education, and retail, OpenRAN isn't just another way to build a RAN. It's flexible, programmable platform that adapts to each industry uniquely. That's why it makes far more sense for vertical deployments than one-size-fits-all traditional RAN. Let's move to our fifth point here. Technical deployment considerations. So moving into the detailed planning and engineering aspects of indoor OpenRAN rollouts. This includes spectrum choice, licensing, front haul and backhaul design, interference mitigations, energy strategies, and compliances with security and safety standards. So let's look at, for instance, the spectrum planning. You need to pick bands based on the penetration versus capacity. For instance, do you need CBRS? Do you need N77? Do you need band N78? These bands will serve most indoor footprints. And also millimeter wave targets hot zones. So you need to align with local licensing if you have PAL. And you design also, you need to design for coexistence to avoid any co-channel interference with neighboring systems. So spectrum planning is important here to consider. Also backhaul and front haul. Fiber is usually ideal, but you can have also Ethernet and E-band or licensed microwave to bridge where fiber is not available. But for split 7.2, which is used in ORAN, the actual front haul latency is less than 250 microseconds. This will definitely ensure adequate capacity for your applications. This is one of the most strengths of ORAN. Also, you need to look into Wi-Fi coexistence because you coordinate channels and power with enterprise Wi-Fi, especially for 5 gigahertz and 6 gigahertz spaces. And when you share the channels, there is something called LBT, which is listen before talk. This is some kind of a standard that you use to avoid any interference. So you need to actually avoid placing the RUs near dense access points. Number 4 is the energy and space efficiency. You prefer always, we go by PoE, which is power over Ethernet, or low power DC, short cable runs. We consolidate the DUs in the existing IT rooms. So all these tactics will reduce OpEx, and also you can use the sleep policies where the RUs can go into sleep mode if there is no traffic, and just wakes up when traffic is there. Finally, is the security compliance, and 3GPP use the IPsec TLS on front haul and back haul, and it's integrated within the enterprise security policies. It's already it integrates so seamlessly. So this is something it is also considered when you for technical deployments. All right, then business and operation models. So, various ownership and operational structures can be applied to indoor OpenRAN. So we can now compare the MNO-led, enterprise-led, or neutral host managed services and hybrid models. These are, 6 different operational / ownership models that you can have when it comes to OpenRAN. So MNO-led, this is where the actual operator extends its macro network indoors, and they own, they actually own the network and the SLA end to end. When do you use this? This will minimize, integration effort for the enterprise, but also it depends on the carrier timelines and economics. So it's ideal where you need strong public coverage, and you don't own the spectrum, so the spectrum is licensed, so it's not like CBRS. Now, enterprise-led model here, the enterprise owns spectrum. When I say own spectrum, it's like CBRS pals. You can actually own some channels within the CBRS infrastructure, and integrating the RAN and core with IT also is possible within the enterprise. So this actually maximizes the control and data sovereignty, because the enterprise now own the network end to end. So it requires some vendor support and SLA to get the network up and running and upgrade, and always need to be upgraded accordingly. So this is another model. Then you have the neutral host. This is like a third party deploys, shared indoor RAN and leases capacity to multiple MNOs via MOCN or MORAN. So this works well in malls, airports, and stadiums. This is another model. And finally, or not finally, actually, just before, the number 4 is the managed services, which is now RAN is delivered as a service with predictable, OpEx and SLA-backed performance. This suits enterprises that want guaranteed outcome without building an RF team. This is the easiest way to do it. Just you have managed services to do everything for you. And finally, you can have the hybrid model. Well, you can actually combine strengths. You can provide your own RAN while leverage on MNO, spectrum and core. So this splits the risk and capacity expansions. So these are the 5 operational models when it comes to OpenRAN. Finally, future outlook. If we talk about forward-looking trends and emerging technologies, OpenRAN will actually benefit from any future outlook and technologies. I mean, if you look at the coverage, for instance, public and private 5G will interwork more tightly. This is known. It will, public and private 5G will interwork more tightly in the future. So you expect indoor OpenRAN to serve dual roles, enterprise applications and public subscribers coverage as well. AI optimized RAN. We have 2 kind of apps, it's called near real time. This is the X app, and then the R app, it's called also non-real time RIC. They will drive, these apps will continuously drive continuous optimization, beamforming, anomaly detections based based on live telemetry also. Third part is edge computing integration. I was talking about edge, which is the MEC, the mobile edge computing. That actually it's the the apps and close to the DUs. They need to deliver sub 5 millisecond response. It's for machine visions and safety systems. So RAN topology. So data stays local in this case. It's good for privacy and latency and also costs. Policy and regulations, shared and local licensing models. You have the CBRS, which is actually, you can look at it as shared spectrum. It will continue to accelerate private and indoors networks. So open interface guidance from standard bodies and regulations will reduce barriers for multi-vendor deployments. This is looking into the future. Finally, the market growth, it's expected like 25% of CAGR for indoor OpenRAN through 2030. So that's not bad. As enterprises digitize operations and spectrum access broadens. So early adopters will benefit from compounding operational data that improves RF design and automation going on forward. So we come to the last slide here where it's architecture. Don't let this scare you. It looks at it as a stack. So here we start on the bottom stack, which is the OpenRU. This is the radio unit. We, as BiCells, we have this product. So, at the foundation, we have what's called ORU. If you look at this graph, this handles the physical layer, low layer functionality. It includes the RF and antenna operations. So the actual OpenRU is just a device. It's a radio for RF and antenna operations. It doesn't have any intelligence. It connects to what's called distributed unit, which is through open front interface. It's called 7.2, as you can see here, 7.2. This is the actual, the most important innovations. It allows operators to source radios and DUs from different vendors. So next to the DU or DU, the ODU is also can be, it is just any commercial off-the-shelf hardware that you can use with virtualized infrastructure. Then we have the centralized unit, which is the OCU. This is split into control and user planes, and it connects to the core. You can see here there are like two interfaces that connects to the core, which is N2. It goes towards the AMF, which is the control, and then N3 towards UPF, which is actually the data. All your data flows through N3, the actual data, but control signals go through the N2. If you go up through the stack, you see that there is what's called the near real-time RIC. RIC stands for RAN Intelligent Controller. This has the actual apps. The near real-time operates. The time scale is between 10 milliseconds and 1 second. So any app that needs to be within this range, it's called near real-time app. Something like you manage mobilities, quality of service, interference. All these are third-party apps, by the way. That's X app. Then you have the then we have what's called the non-real-time REC, which it operates above 1 second. So it provides policies, sound-like functions, and machine language, and it is through our apps. And finally, you can see we have the orchestration and automation. This is like it's like an umbrella over the entire system. It's for orchestrating the entire and procedures. So this layer handles like end-to-end configuration, policies, inventories, and automation, connecting down to the REC via A1 interface. So all these interfaces you see in red, F1, E2, A1, all these are open interfaces, and this is the magic of OpenRAN. So you can mix and match from different software companies, different hardware companies to create your use case in a system. So from the radio layer up to orchestration, OpenRAN disaggregates the stack into open interoperable components, making the RAN more flexible and multi-vendor and innovation ready.
Hey, Maji.
And this will conclude the presentation. Yes.
And Maji, I think you did a good job of covering a lot of activity and a lot of subjects in just a little bit of time.
Gary, I can't hear you. Mm-hmm.
Cool.
Yeah, I'm done.
Okay, can you hear me now?
Yes, I hear you now.
Okay, good. Perspective, I just wanted to make sure everybody got, I think what we learned in this is what you thought. ORAN is complex, and we're just at the start of a neat product that's going to be impactful for the next 5 or 6 years. So as you have those opportunities, both within your company and within partners, feel free to reach out to Mike at Winncom or Maji or myself at BuySells. It's not like us to cover products that interact with other products, but we feel like our place is right in the middle of all this ORAN activity. So we're going to send the presentation out with Dawn's email, and just feel comfortable ask questions. I think from our perspective, the most important thing is that we're involved in this conversation, not that we understand everything. So it's okay to come to us and say, hey, could we just talk through what you talked about on the webinar, and we kind of move forward together. So it doesn't look like there are any questions that came in, but feel free to reach out anytime afterwards, and we're happy to review any of those individually with you.
Thank you. And as Gary stated, I'm just going to reiterate that one, we'd like to say thank you to the presenters and those who were able to attend, but definitely keep an eye out for a follow-up email. It will include all the links of the information you just learned and ways to contact. So again, thank you all for joining, and I hope you have a wonderful rest of the day.